All right. I have my specs on. I know you guys don't usually see that, but it's still Miss Middleton. I wanted to, and what we need to do is we need to go over notes. I want to point out a couple things to you really quickly, though. One, your bell ringer is still in the same place. We've probably already gone over this. It's right there. But there is another new couple things. We are moving on in our Unit 1 Foundations of Science, and I know this might not be your class right here, but they're all set up the same. So you should have your Unit 1 notes right inside of this Unit 1 Foundations of Science folder. Then you have your Unit 1 study guide, and what that means is that a test is coming up. Okay? Whenever I give you a study guide, and we'll take a quick look at it, whenever there's a study guide, that means be aware. Test is a brewing. Okay? So, we have here your study guide, and you should probably work on it. I have only given extra credit for this usually. Um so I would definitely start working on it. Your test will possibly be next Monday. So today you watching this, it should be the 1st of February, so I believe that'll be what, the 7th or 8th, right? Next Monday. Next Monday will be your test probably. And you need to know how to do this stuff. Graphing. We'll talk about convection later this week. Parts of lab stuff, scientific method, graphing and slope, your different convection and stuff like that, and density. Density is probably down here. Yep. Density is what we're going to focus on today. So I would start working on it. Most of this you've already seen before. The only two things we need to get through still is density and convection. So if you go back here, I want you to open up your notes. Remember, your notes are right here. And we do have another folder. We are starting Earth System Sciences or Science, which is your density and convection. Okay? So, right here's your Unit 1 notes. Go ahead and open them. And let's get started. Now, for some of you, your notes are going to look a little bit different, but it's the same content, okay? And on this Edpuzzle, it'll stop and start it so that hopefully you can get the information you need. So, density, what is it? It's the amount of matter packed or spread out in a certain space. What do we mean by amount of matter? When we're talking about like the atoms inside, that is considered the mass, all right? And how much of that stuff, that those atoms are packed or spread out into a certain space, that space we're talking about volume. Okay, so when it comes to density, mass is involved and volume is involved. All right, so let's talk about the tools you might use to measure density. Okay, so is there a single tool used to measure density? Well, because you have mass and you have volume, there's two separate things you need to take into account. So no, it will be more than one tool that you use. So for mass, we will always use a balance, okay, and it'll be in grams. So a balance, think for a balance maybe when you go to the doctors, and you step on, I guess it depends where you go now. Back in my day, they had like the little slidey thing where they would always start it at 0 and you would step on and then they would slide the little things down. That's a balance. So a balance takes out gravity and doesn't factor it in. The scale in your house, when you step on it, it's taking in how much gravity is pulling down on you. For mass, you probably use them in your other science classes. You always have to like zero it. That's to take gravity out of the equation, okay? And it's always in grams. Volume, it depends what you have, what shape the object is. So volume is all about shape and about space and how much it's taking up. All right. So if it's a straight or flat edged object, you will use a ruler and you will find length times width times height. That's like a normal straight edged object. And because you're taking like whatever it is by centimeters times centimeters times centimeters, the unit for that is centimeters cubed. Okay. Now let's say you find a weird rock, or you want to find the volume of a ring or something weird shaped that's not does not have flat sides. You would use a graduated cylinder. Okay. So what this is usually called is water displacement. So you put water into the graduated cylinder, you take account of how high it is in the graduated cylinder, you throw in like, or not throw, you slide in the ring or the rock or I don't know, whatever you're trying to find the volume of, and you count how high adding that made the water go. Okay, so you are figuring out the volume of just that object by seeing how far it moves the water. Okay. Okay, because you're adding that volume to that water. Anyway, so no matter what, to find density, you need to find the mass and you need to find the volume. Our lab, you are going to have to find the mass, use a balance, and you are going to have to find the volume of certain objects. And for that, you'll be using a graduated cylinder. You take those two, and we're going to look at the equation. All right. So the equation is mass divided by volume. So you take whatever you found when you put it on the balance, and you divide it by whatever the space is that it takes up. So whatever you found in the graduated cylinder. We found that mass is always grams. So at the top, you always have grams. And then depending what you're looking at or your object, it'll either be centimeters cubed if it's like a straight edged object and you did length times width times height, or it'll be milliliters if you use a graduated cylinder. They both transfer equally. So if I have 1 gram per centimeter cubed of water, it would equal 1 gram per milliliter. They're equal to each other, which is weird, but hey, it makes calculating very, very easy. Okay? All right, so we're going to watch this quick video, and you're supposed to think about 3 things and also use this diagram to come up with 3 things that are helpful or that you can take away from this. Takeaways. Here we go.
Hi. Today we're going to explore the concept of density. When most people hear density, they think of mass divided by volume. Well, that's the formula for density, but what does it actually mean? Simply stated, density is a ratio of an object's mass and volume. Mass is the amount of matter or stuff that's packed into an object. Volume is the amount of space an object takes up. When you put it all together, density is the amount of matter, the amount of stuff, that's packed into a certain amount of space. The more matter that's packed in, the more dense the object is. For example, here's a cup with some cotton balls in it. As you can see, there's still a lot of empty space in the cup. If we were to put more cotton balls into the cup, we would increase the density because now there would be more matter packed into the same amount of space. Brownies are another great example of density. Do you prefer your brownies light and cake-like or thick, fudgy, and dense? I like the light and cake-like ones myself, but the difference between the two really is just how much matter is packed into that brownie. An object's density determines if it will sink or float. Liquid water has a density of 1 gram per milliliter. If an object has a density higher than 1 gram per milliliter, it will sink. If the density is less than 1 gram per milliliter, it will float. What do you think will happen if an object's density is exactly 1 gram per milliliter? That's right, it will stay suspended right in the middle of the water. Density is a useful way to identify unknown objects because materials always have the same density, and we can prove this mathematically. Let's take a look at this figure. This rectangle, let's say that it has a mass of 100 grams and a volume of 50 cubic centimeters. If we use the formula and we do mass divided by volume, we calculate that the density is 2 grams per cubic centimeter. Now let's cut the object in half. When you cut it in half, the mass gets cut in half, so now the mass is 50 grams. The volume also gets cut in half, so now the volume is 25 cubic centimeters. When you use the formula, we end up with the same result. The density is 2 grams per cubic centimeter. This is true because if you cut an object in half, you're having both of the mass and the volume, so the ratio between them is still the same. So let's say that I gave you 5 different size pieces of the same uniform material. You now know that they all have the same density because they're all the same material. If we were to plot their mass and volume on a graph, it would look like this. You'll notice that the 5 points represent the 5 different pieces of the material. If you pick any point on the graph, say this one, and divide its mass by its volume, you can determine the object's density. No matter which point you pick, the density will always be the same. For example, if we pick this point, density is the same. Or this point, density is the same.
Okay. So we're not going to move on to dispersion just yet. But on your notes, let's write. There we go. Let's write down the big takeaways you might have gotten or you should have gotten. And also for those of you who are like, oh my gosh, how do I mess with this? Well, remember the equation is mass. Oh, you just double click. Mass divided by volume. Just to recap with you, save that. And then you have, oh my goodness, grams per centimeter cubed. Ew, why did it do that? Centimeter cubed. Got it. Save. Or grams per milliliter. Boom. Okay, so hopefully you guys got that. If you didn't, just went over it right now. So write that in there. All right, the big takeaways. So one big thing that I'm like, man, that was really good that he said that, is a substance will have an equal density no matter what size it is. So like if I have different, so for example, I'm going to write an example. Gold will have the same density no matter its size. Okay, I'm going to move this over here. It's kind of gross that didn't work that way. Okay, another thing that I want you to look at is this picture here. So what you're seeing is that volume, the boxes, stay the same, but the mass increases. And you'll notice that the density increases too. So if volume stays the same, but mass increases, like this image, volume stays the same, mass increases, density will increase. Okay? Whereas if, so I don't know if I have paint on here. I have Google Drawings. Let me show you. Google Drawings. Boop. Bam. So let's say then the volume changes sizes. So I'm going to take some boxes. Here's the first one. Let's make it bigger. Boom. Boom. Here we go. Okay, but I put, let's see here. So I want these to be 1, 2, 3. Okay. And the, ooh, nope. And the mass stays the same. You can see that density is going to decrease. There's less stuff. Like, this is the densest, less dense, the least dense. Okay, so that's something I want to point out too. So if mass stays the same, but volume increases, the density will decrease. It will become less dense. Okay, so those are the notes for today. Ya done. Have a good one.